Alright, you're on.
What we're doing today is demonstrating a Watch Technologies gate, actuator, and master RTU base station all linked together. This is a demonstration system that's designed to basically show how the system works. It's certainly not designed to show all of the capabilities that the system has, but in this case what it's going to do is demonstrate that we can set a gate position and that will in the base station, and that this gate position will then be radioed to the actuator, which will then search for that gate position, and we'll be able to see a whole bunch of activities associated with that. What we're looking at is a gate, an actuator, and a master RTU. On the side of the gate, on the right hand side of the gate, you will notice that there's a tube of water with a depth transducer in it. That depth transducer is meant to demonstrate or show that we can measure water and get that data back to a base station. So in reality, this whole system could be deployed in a canal or in a ditch or in a reservoir, and it would maintain a certain amount of water coming out from a specific gate position. We'll see how all that works in a minute. Right now I'm going to open up the actuator so you can see the inside. This is the face of the actuator itself. Now this actuator is in fact a combination actuator and RTU. What we've done, the only thing that we've done, is remove one of the screws on the faceplate so it's easier for us to remove the other one. And I'm going to remove the other screw right now so you can see the inside. And this is the wiring for the actuator system. Now what you're seeing is a gear motor, and this gear motor here is a DC actuated system. That means direct current, and it's a very strong, very robust motor. We have 3 flavors of them: light duty, medium duty, and heavy duty. This is the motor that runs it. These are the sprockets. Those are 2 sprockets that can be that are used in a variety of combinations to get different gear ratios to make this system work more or less torque. This right here is a position sensor that's mounted to tell you exactly what position the gate is in at any given time. A battery. The battery is always in these systems because it's a DC system. It needs to have DC power to run it, so therefore you have a battery, and that means you also have a standby power. In this case, we also have a radio, a 900 megahertz radio. We can have a variety of different radios that we can use. In this case, it's this small XB 900 megahertz radio, which is very effective at medium to short distances. These are our relays that allow the motor to go up and down. You pulse the motor with one relay, it goes in one direction. You pulse it another, it goes in another direction. And generally speaking, this is how the whole system is wired up. It's pretty simple, pretty straightforward. I'm going to turn it on. That's the general computer system that's on. And here's our run 3. There are various different kinds of computers that we can use, or RTUs that we can use. This is the one that we like for this particular size. This is the auto, manual, and off mode to control the system, and this is up and down. If we're in the manual mode and the system is on, the gate goes up, the gate goes down. Now, in this system, if you want to run it fully manual, you take the key out, and then the gate runs by the hand wheel, up and down, either way, in case it's failed for any reason, the motor to work. Now we're back in working off of the motor again. As you can see, it's not going to move easy. All right, so we'll put it back together again, and we'll demonstrate some of the functionality of the system. Let's go over to the RTU over here, and you can see how this guy looks. It's another Rug 3, same model as this, only this one is designed to be used as a master. This is designed to be used as a slave in this particular case. It's all a matter of software. We turn the unit on, we turn the radio on, we're ready to rock and roll. Now, in this case, what I'm going to do is I'm going to manually move the motor to any given position, and I'm going to put the system in auto. And what you can see now is that the system's trying to self-adjust to get to its set point, which in this case is 0.75 feet. And that would be 7.75 feet of opening of the gate at the bottom. So we've got this program to run pretty fast. It's going to make adjustments every few seconds until it gets to within 1/100th of a foot of 0.75 feet. And we'll let this go for a little while, and I'll explain some other things in the meantime. These systems are designed so that you can change set points in the actuator at a distance. Now, of course, this one master can be running any number of slaves, but in this case it only has one that it's working. So what we want to do is we want to go to look through the screen, and on this particular screen we have its address, we have the battery voltage, we have the gate position, we have the level of the sensor over there, the levels that it's reading, and we have a target position. That target position is what we want to demonstrate today. We also show our receive and our transmit right here, so that when we try to poll the system, one to poll it, we see that when we get a 1 in each column, that we've not only transmitted our information to it, but we've received information back from the remote target. So now we can go down to, we see that this is the name of the program that's in there, and the next page, or the next sequence, which is the gate control section of the software. You have two screens here, a main screen and a gate control screen. The main screen displays the information that you would see generally that you're interested in. The gate control page or screen lists information specific to controlling the gate. What we're seeing now is the gate position that the gate is at right now. It is at 0.76, which is within the 1/100th that it's supposed to be. I don't know why it's not stopping. It should be, it's going back down and trying to hit it again. 1/100th, it's gonna go and find it. So the level is 1.59. The target is 0.75. Oh, I know. I think it's because we have our tolerances so close, our set points. I'm going to go back to here, and we're going to go to our set points over here, and we're going to check our set point to see how close we are. Our set point in this case, our deadband, is 0.01. So we should be trying to get within 1/100th of that. Let's stop.